Good morning, 7th grade. This is going to be part two to our fantastic videos for the week about scale drawings, okay? Today we're still talking more about our constant proportionality, scale factor, rate, ratio, all these words that essentially mean the same thing. But now we're taking it into the second dimension. Instead of just lengths, we are actually trying to compute actual areas from our scale drawings. Okay, so this is very much related to our last video that we had earlier this week. So if you have any questions, again, you know how to reach out to me. But without further ado, let's get to the video.
All right, everybody. Today we're going to be computing actual areas from a scale drawing. Now, this is very similar to our last video where we were computing actual lengths from a scale drawing. So we're taking it that one step further. So we're going to need to remember some of our area formulas, basically like length times width, half times width times height. We'll kind of see what we come across. I'm betting that we'll mainly say area equals length times width. So let's start with our first example. So use the diagrams below to find the scale factor and then the area of each figure. Okay, so in order for me to find a scale factor, I need to make a table. Sorry, little turkey. So this is going to be the AP is going to be actual picture and SD is going to be scale drawing. So I'm going to line things up. Going to color coordinate them as well. So I have 4 and 8 and 3 and 6. Well, I know that my actual picture is going to be my X and my scale drawing is going to be my Y. So if I do 8 divided by 4, I get 2. And if I do 6 divided by 3, I also get 2. So I know that my scale factor is 2, right? And they also call scale factor R, just so everybody knows, okay? So now I need to figure out my area of my actual picture. And again, area of rectangles is length times width. So I'm essentially doing area equals 4 times 3, which is 12 square units. The scale drawing of my actual area is A equals 6 times 8, which is 48 square units. And I think I can take some of this stuff out because we know how to find our area by now. Value of the ratio of the scale drawing to the actual area. So they want me to create a ratio using my scale drawing area and my actual area. So I'm going to do 48 divided by 12, and that's equal to 4. Here's what I want everybody to think about. How can I go from my scale factor of R to my ratio for my actual area? Essentially, how can I go from my scale factor to this other factor, the ratio of the areas? Well, I can do 2 times 2, and that gives me 4, which is the same thing as 2 squared equals 4. So in this case, if I want to go scale factor to the ratio of the areas, essentially what I can do is R to R squared. So I could just square my scale factor, and that is automatically going to give me my ratio of areas. Okay, so let's try to do our next problem in 2 separate ways. One including this way, and another including another way that we would probably like. So, bringing back our example from our last video, the student government liked your half-court basketball plan. They have asked you to calculate the actual area of the court so that way they can estimate the cost of the project. Based on your drawing below, what area or what will be the area of the half court? Well, in our last video, we found that the length and width of our actual were 25 feet by 30 feet. So our first method of finding the area is just doing area equals 25 times 30 feet, which is going to give me 750 feet squared, or square feet. Okay? So that's our first method of trying to figure out what is going to be the area of our actual image instead of our scale image. But what happens if we don't know what to do in this case? So I'm going to take that in our second approach. So the first thing that I need to do is I need to find the value. I need to find essentially my r squared value. So I take my r value, my scale, which I know is going to be 15 over 1 based off of the information that they gave me. So my r squared, or the value of my ratio of areas, is going to be 15 over 1 squared, which is equal to 225. Okay. The next thing I need to do is I need to find the scale drawing area. Scale drawing area. So essentially what I do is I need to do 2 times 1 2/3. That's ultimately going to give me 10/3 square inches, or inches squared. So now here's what I need to do. I need to take this idea of an equation and I need to use it in order to help me find my new area. So let's say that x is the scale drawing and y is the actual area, or AA. I'm going to take my idea of writing equations from proportional relationships, scaled relationships. Remember that y equals my rate or ratio, constant proportionality, times x. So in this case, it's y equals my k, or r squared, which is 225, times 10/3, which is my scale drawing area. Oops, let me put that in there, area. So 225 times 10 divided by 3, well, that actually comes out to be 750 as well. So I know that the actual area using the given scale is 750 feet. So that's just two separate methods for us to try to figure out what the actual area is going to be. No one method is more correct than the other. I really encourage you to do whatever is best for you and what you understand more. So let's go into our wrap up. So our lesson summary, and let me zoom in a little bit here if I can. Whoops, too much. So given the factor r representing the relationship between scale length, or scale drawing length, and actual length, the square of this scale factor, r squared, represents the relationship between the scale drawing and the actual area. So that's important to know. R is for scale drawing lengths and actual lengths, our lengths. R squared takes us into that second dimension when it comes to scale drawing area and actual area. For example, if 1 inch on the scale drawing represents 4 inches of actual length, then the scale factor, R, is 1 over 4. On this same drawing, 1 square inch of scale drawing area would represent 16 square inches of actual area, since R squared is 1 over 16. So that's the end of my video. If you have any questions, feel free to message me on Schoology or leave a comment in the comment section below. Feel free to like and subscribe. Until next time, I hope that you all have a great day.